بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الديناميكا اسمه الدفع. طبعا احنا عارفين الدفع ده مهم جدا جدا في حياتنا اليومية. كتلة أو جسم بيتحرك بكتلة، طالما بيتحرك بكتلة يبقى له سرعة. حاصل ضرب الكتلة في السرعة هو ده اسمه الدفع or momentum. Welcome my dear student in our math program for second 3. Today we are taking your lesson in dynamic subject. Its title momentum. What is a momentum? Look at introduction about momentum. My dear student, what is the momentum? Momentum of moving a body is a vector quantity of the same direction of the velocity of this body, and its magnitude at momentum is estimated by product of the mass. The momentum vector is its symbol H vector, mv vector. My dear student, momentum is product mass and velocity. Mass of the body, its symbol m, without direction, but velocity has direction, and also momentum has direction. In case of rectilinear motion, each h and v are parallel to the straight line in which of the motion occurs. Each of h and v can be expressed in terms of algebraic measure h equals mv vector. H vector equals m, v vector. M represents the mass of the body, v represents the velocity of the body. Measuring units of momentum, the magnitude of unit of the momentum equals mass unit times velocity unit. Therefore, h, its unit kilogram meter per second. Why? Because mass, its unit, mass unit kilogram, but unit of the velocity meter per second. Then what is the unit of momentum? Kilogram meter per second. Why? Because momentum product of mass and the velocity. Mass, its unit kilogram. Velocity is meter per second. My dear student, look at the first example. Calculate the momentum of a bike whose mass is 35 kilogram and moves uniform speed of magnitude 12 meter per second towards east. My dear student, look at the solution. H equals mv. H equals product of mass and velocity. 35 times 12 equals 420 kilogram meter per second. This same towards east, or the same direction of the velocity. Another example. My dear student, we have a car of mass 2 tons moves in a straight line such that x represent distance or displacement function in t. 3t square minus 4t plus 1 vector c vector equal of mass 2 tons moves in a straight line such that x is function in t 3t square minus 4t plus 1 in c vector, where c is unit vector in direction of motion of this car. If x is measured in meter, what is the required? Find magnitude of the momentum of the car when it starts to move after 3 seconds of its motion. Solution. My dear student, the momentum product of mass and velocity, but in this example we know that the value of velocity is not found, but before that we know that the velocity equals dx over dt. What is the velocity? Differentiation of displacement respect to time t. We have function x is derivative with t time. Then at the first we find the velocity v to multiply by mass of the body to calculate the momentum of the body or of the car. Its mass 2 tons. What is the velocity? At the first, find the velocity v from differentiation dx with time t. After that, find the momentum by using product mass times velocity. Look at, my dear student, the solution. Look at, my dear student, we have x function with t, 3t squared minus 4t plus 1 in c vector. Velocity equals dx over dt. Differentiation respect to time t, 6t minus 4. Unit vector c. This is a vector. At beginning of the motion, t equals 0. Then v equals negative 4 in c vector. Therefore, we deduce that h equals mv. H is momentum equal mv. Therefore, m equals 2 tons. 2 tons equals 2000 kilogram. Time is negative 4 equals negative 8000 c vector. But magnitude of momentum equals what? 8000 kilogram meter per second. Why? Because unit of the mass was 2 tons. We convert it to kilogram, and the velocity with meter. Therefore, meter per second. Velocity meter per second. Why? Because x or the distance was in meter. Then the momentum or magnitude of momentum equals what? 8000 kilogram meter per second. When t equals 3 seconds, by substitution, velocity equals what? By substitution v nv with t equals 3 equals 14 c vector. Then h equals mv. M equals 2000, v equals 14. Answer is 28,000 c vector. Magnitude equals 28,000. Magnitude of momentum 280,000 kilogram meter per second. The change of momentum represent is delta h. What you mean of change of momentum? If a car has mass and velocity, moves from 2 point A to B, this is a change of momentum. Change of momentum equals m change of the velocity. Car, its mass constant, 2 tons, but velocity is variable. Therefore, the change of momentum equal the product of mass times the change of its velocity. When m is mass of the moving body, delta v is value of its velocity. The change of momentum of the body equals m multiply v2 minus v1. If the car moves from A to B, v1 represents the velocity at A, v2 velocity at VB. Therefore, delta h equal m multiply bracket contains v2 minus v1. Therefore, acceleration is a moving a body equals what? By using acceleration, we find delta h. Why? Because a change of velocity is acceleration. Delta h equal k constant integration from t1 t2 acceleration a delta t or dt. Example. My dear student, rubber ball of mass 200 gram is led to fall on horizontal surface up from a height of 90 centimeter. Rubber ball of mass 200 gram is led to fall on horizontal surface up from height of 90 centimeter to rebounded up to height of 40 centimeter. Calculate using kilogram meter per second unit magnitude of a change of momentum of the ball as result of impact. Solution. My dear student, we have a rubber ball. Rubber ball has mass. This rubber ball, when fell on the ground, then the initial velocity equals 0. When a rubber ball fell in the down or in the ground and rebounded with other velocity, then the ball will reach the ground with his velocity. After that, it return bounded up with distance with other velocity. A change of the velocity equals what? A change of the velocity in this case equals a change of momentum. My dear student, look at the solution. Look at, my dear student. This figure represents when rubber drop down. V naught equals 0. G gravity force 980 centimeter per second square. Distance equal 90 centimeter. After that, look at C unit vector of motion downward and bounded by S equals 40, G equals 980, but V final equals 0. Look at, my dear student, V square equals V naught square plus 2GS. The first required, or we must find V of the rubber ball when touch the ground by using V square equal V naught square plus 2GS. Z equals by using substitution the velocity 420 centimeter per second. After that, my dear student, in this case of rebounding, V square by the same the rule V naught square plus 2GS, but in this case V final equals 0. Then by substitution 0 equal V square minus 2 times 9.8 times 40 equals what? Equals 280 centimeter per second. We have two velocity. Change of momentum equal m times v2 minus v1. Therefore, delta h equal, by using this rule, 200 over 100 over 1000. Why? Because mass of the rubber is gram, but in this case the unit of momentum kilogram meter per second. We convert gram to kilogram by divided by 1000 and change the velocity from centimeter per second to meter per second. Therefore, the change of momentum equals 200 over 1000 multiply bracket contains negative 2.8 minus 4.2 equals what? Negative 1.4 c vector. Therefore, the momentum in magnitude equals 1.4 kilogram meter per second. Look at, my dear student, another example. Body moves in a straight line such that acceleration of its motion A is given as a function of time t by the relation. Remark, my dear student, we have acceleration 2t minus x, where A is measured in meter per second square unit and t time in second. Calculate the momentum of the body in the time interval t more than or equal 3, smaller than or equal 5, if the mass of the body is 8 kilogram. My dear student, remember, my dear student, we take rule when find momentum by using acceleration equals what? Delta H equals K is the constant. Integration from T1, T2, acceleration dt. My dear student, look at mass equals 8. The integration or finite integration from 3 to 5 about acceleration A. A equals 2t minus 6 respect to time t. By using integration, therefore 8 multiplied t square minus 6t from 3 to 5 equals 32 kilogram meter per second. Look at, my dear student, another example. My dear student, we have relation between displacement, velocity, and acceleration. Look at what is the relation between S, V, and A by integration and by differentiation. My dear student, when find velocity and the given S, we make differentiation. Why? Because velocity equals ds over dt. If the required acceleration and the given velocity, we make differentiation. Why? Because A is dv over dt. But, my dear student, differentiation is a vector average velocity vector VA equals what? SF final minus ST over T2 minus T1. My dear student, instant velocity V equals ds over dt. Acceleration equals dv over dt. In this case, we use differentiation. But, my dear student, if we have acceleration and the required velocity or displacement, what you do? If we have acceleration from given, the required is velocity, we make integration. If the given velocity required displacement, we make integration also. Look at, when VA more than 0, product of the velocity and the acceleration equals more than 0, this is accelerated motion. But when VA smaller than 0, the motion is decelerated or retardation. This important rule also, we have two types of motion: accelerated motion, decelerated motion. When the required proves that the motion is accelerated, we can prove that product of V and A more than 0. How to calculate VA more than 0? Maybe V equal negative, must A is negative. Negative times negative equal positive. When the velocity is negative 10, as example, acceleration negative 5, negative 10 times negative 5 equals 50. 50 more than 0. This is accelerated motion. But when the required how to prove the motion is decelerated or retardation, one of V or A must be more than 0, negative. Why? Because when multiply V times A must be smaller than 0, is decelerated or retardation motion. Then we have two motion of the body: accelerated motion, decelerated motion. Accelerated motion, VA more than 0. Decelerated motion, VA smaller than 0. What is the V? Velocity. What is the A? Acceleration. My dear student, V function of S and S function of T. Remember, my dear student, the velocity function of S. What is the S? Displacement. Also S function of T. T as time. Acceleration equal dV over ds times what? ds over dt. This important rule. Acceleration, differentiation, velocity respect to displacement times differentiation, displacement respect to time t. Then we deduce that acceleration equals v dv over ds. Why? Because v equals ds over dt. Therefore, we find acceleration by using velocity times dv over ds, or acceleration v d2s over d2 square. What you meaning of d2s? Higher derivative or second derivative of displacement respect to time t. The first derivative of s respect to time t is velocity, but dv over ds equals d2s over dt square. Multiply v is called acceleration. Then we know more definition or more values of acceleration. Maybe acceleration equal dv over dt. Maybe acceleration A equal v dvs dv over ds. Also, we can use acceleration equal v d2s over dt square. Integration of vector f. S equal integration v respect to time t, the given velocity, the required s. We use integration. Why? Because s equal integration v respect to time t. Also, V equals integration of A respect to time t. Velocity, acceleration, integration of acceleration respect to time t. V equals Vs, S equals Gt. Therefore, A equals dV over ds. By using integration A ds equal integration V dV. Therefore, my dear student, integration or finite integration V naught V dV equals acceleration or integration from T naught T A dt. Therefore, integration V dt equals integration ds. Integration V dt equals integration ds. My dear student, by the end of the lesson, we know that how to find acceleration and velocity if the given is displacement or the reflex required. How to find the value of displacement if we have acceleration. At the first, we find integration of acceleration to find or to calculate the velocity. After that, we make integration of the velocity to calculate the displacement x. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.